So now let's discuss a problem everyone in this room has felt. Risk assessment in space programs is paperwork heavy, slow, and ages quickly. So can natural language processing help cut that load? To talk about this, let me introduce Martin Kemken, that's you, and Fabian Bauer. They are both security engineers at Telespazio, Germany, the German entity of the Leonardo and Thales joint venture. And of course, they have a deep heritage in Galileo, Copernicus, and other missions operation. Please welcome Martin and Fabian.
Yeah, fantastic. Hi, everyone. I'm Martin. Today we talk about risk assessment and how language models can support this activity. To make sure everyone here starts on the same page, what are risks, or especially cybersecurity risks? Well, a risk does always appear when we have an event with a specific likelihood to appear and some negative impact. And these two parameters are taken together into a formula. So whenever either the likelihood or the impact does increase, the final risk does increase as well. So in practice, so many of you might know the concept of a risk matrix. In practice, we usually deal with discrete values for likelihood and impact. And such a risk matrix basically implements the formula we have seen before. In this example, with 3 possible likelihood values, 3 possible impact values, and you can see how they map to the respective risk outcomes. So why do we do risk management at all? Well, first, risk management is the foundation for to implement security controls. If we do not know what we have and what we need to protect and how it is threatened and which components are more threatened than others, there's basically no justification to implement countermeasures. And besides that, there's an extrinsic motivation since risk management is mandatory for each company or institution in critical infrastructure sectors. And as we all know, space is one of them. So how does risk management look like in practice? We have chosen the ISO 27005 risk management standard, and I'm sure many of you have heard about it already, since it's just one of the most prominent risk management frameworks. In general, I would like to say that our approach we will present does also apply to other risk frameworks, since, to be honest, they're not so different by their methodology. So how does it start? First, we need to establish a context. That means we need to scope our business processes. What are the key purposes of our institution? We need to collect a risk register. So that means we need to identify devices, physical or virtual. We need to identify information, or we can also identify people which make it possible to implement and to realize these business processes. Then we also need to collect the public threat data. So just to scope which types of attackers are in scope and we would like to protect against. Then in the next step, after we collected all this information, we go over to the analysis, to the risk assessment. Here we begin our analysis with which are risk origins or attacker types, and what are the target objectives they try to realize against our institution and with how much effort. After we identified these pairs, we can build up end-to-end scenarios by identifying the technical field events which lead to realization of these target objectives. And at this point, we can also evaluate what the impact of a successful realized attack is, and what the likelihood is to pass through the different steps and pass an attack path successfully. In the end, we come up with a risk register, basically a list of different scenarios. And now we need to decide which of these risks are acceptable to us and which need to be reduced. So where do we need actions? One other question is, do we actually accept the outcome itself? It might also be possible that we come up with the insight that we actually need more information and we need to go back to the context establishment first. But if everything goes well, we continue with the risk treatment. So now we need to identify the security controls which effectively address the risks we are not willing to accept. So yeah, which security controls reduce the likelihood and the impact most effectively. Also, what is actually the cost of implementing a security control? Of course, it does not make sense to implement a security control which is more expensive than the impact of the respective event that we would like to address here. So this risk management process is controlled by monitoring and communication actions, but within this presentation and on our approach, we directly focus on the analysis part, on the risk assessment exclusively. So what are the disadvantages and challenges we have identified in the conventional method of doing risk assessments? First of all, risk assessments simply bind resources. So we need experts coming together, brainstorming about scenarios, identifying assumptions, document everything, providing a report, and so on. Then we, by our experience, risk assessments are often performed irregularly or non-periodically. For example, only when an external audit is coming up. And risk assessments are mainly based on discussions of natural language questions. And you might get an idea where we're going here. So our approach is targeting these challenges with language models, with a natural language processing approach. So basically everything can be broken down into one key function, which is basically mapping. We do an element by element comparison of two sets. If we take one example, let's say we have a set of threats and we would like to know which of these threats do we need to respect and which of them do we actually not care in our institution. So we map them against a list of risks and generate a prompt like the following. Is parameter 1, which will be filled with a risk source, capable of causing parameter 2, which is filled with a threat, and provide a short justification and a final risk score. So if we insert the respective values from the sets and prompt this against a plain language model, we might receive an answer as the following. The risk source script kitty describes activities motivated by personal recognition and fun, focusing on basic attacks. In contrast, satellite signal disruption requires professional hardware and increased efforts to install and configure them at suitable locations. Score 0.2, so it's not very high. But if we do this for any possible combination, we end up with a matrix which is looking like this. Besides this mapping operation, we perform an aggregate to reduce the complexity of our outcomes. In this specific example, we might not necessarily be interested into every single likelihood value we have received. Instead, we actually want to know, what is the total likelihood of one threat to appear. So in this example, we perform a maximum operation for over each row. But I mean, of course, technically other functions to perform this reduction are possible as well. But you see, we end up with a one-dimensional matrix, stating the likelihood for each of these listed threats. And at this point, I give over to Fabian.
Thank you, Martin, for the first part. So let's now look at some demo pipeline we have built for this presentation. It's not the complete picture you would have in practice, but it gives you a basic idea of how you would build such a pipeline. And we start with the first step of the ISO in the risk assessment phase, which is risk identification. And as an input, we give the pipeline our business scope. This can be a large description of the business as a text or maybe some documents. And then we give it the set of risk sources and set of threats. Both have examples in the ISO already, but we of course also put in our own ones as well. And then for each pair of risk source and threat, we can ask the model, how likely is the given risk source able to cause the given threat description? And it will give us a likelihood value. And as Martin has shown, we are only interested in the maximum likelihood of threats occurring. So we reduce the result and get a function mapping from threats to a likelihood score. In the next step of this demo pipeline, we are still in the risk identification phase of the ISO, and we are essentially doing the same, this time for the likelihood of vulnerabilities occurring. So we again give the language model our business scope description, the set of threats and set of vulnerabilities. Also, the vulnerabilities have examples in the ISO already, but we add our own, of course, as well. And for each pair of threat and vulnerability, we can then ask the model, how likely is the given threat going to exploit this given vulnerability? And we reduce the result down, we aggregate it again. We can factor in at this time the likelihood of the threats, and we then get a function mapping from our vulnerabilities to a likelihood score. So these two steps were the preliminaries we have to execute, and we now move on to the risk analysis step of the ISO framework. Now we are actually computing risk values, so likelihood and impact. And in this step, as an input, we have the business scope again, the set of support assets. So these are all our hardware, software, people, premises assets that ultimately make up the business functions our business executes. And we have the set of vulnerabilities again. And in this step, we can ask the language model, how likely is the given vulnerability going to weaken the given asset and with what impact regarding confidentiality, integrity, and availability. So we are actually asking 3 questions this time. Then we aggregate this again with the maximum likelihood. We can weigh in the likelihood of the vulnerabilities occurring in the first place. And what we get is a first risk register function mapping from our support assets in terms of CIA, what our likelihood and impact will be. In the last step of this demo pipeline I'm going to show, we don't actually have anything for the language model anymore. It's just about mapping it from support assets to our primary assets. So ultimately, the business functions our business has. The mapping of the support assets to primary assets, this one is left vague because it can look differently in practice. Maybe it's a dependency graph mapping from our support assets to the primary assets. And we take our function that we have computed from the last step, and then our aggregate would, in the case of a dependency graph, just propagate this with a graph propagation algorithm. And what we finally obtain is our risk register function mapping from primary assets in terms of CIA to likelihood and impact. So what we now have is this basic risk register function. But of course, you would be interested in more. You would want to know which controls should now be implemented for the support and business assets. And maybe you would want to have a little more traceability in terms of, okay, what risk origins were actually causing our threats, which support assets are causing our vulnerabilities on a given business asset. So we could extend the pipeline with further stages to also then give us these results. Okay, so now imagine you would take an agentic AI, you have all of your documents, business scopes, assets you have in your business, and you ask the agentic AI, do the risk assessment. It would do it somehow. So what are the advantages of the pipeline we have built compared to this? The first thing is that we are decomposing the task as far as we can, and all of the individual questions we give to the language model are rather small scale. And we reduce our results further down in each stage with this aggregate function to the results we actually need in the later stages. So we can really control the whole process in terms of the amount of intermediate results it's working with. A nice side effect is that many of the tasks can run in parallel. Down below is our demo pipeline again, and all of the steps that are vertically aligned don't depend on previous results, so they can run in parallel. Let's now look at an individual stage of the pipeline. So what do we get there? First, all of our stages we have will of course write their results into trace files. So all of the raw outputs from the language model will end up in a trace file. All of the intermediate results before the reduction will end up there. So we can ultimately look at the results and explain why the language model came up with what it told us in terms of scores. We are debugging each stage in terms of runtime. So maybe sometimes the language model is taking too long. We didn't expect it to give us a huge explanation each time. So we can tune it before we add further stages if we are not satisfied with one. And also we are monitoring the pipeline in terms of error correction failure rates. This is a topic I will come to in a bit. But also if the language model is failing too often, we can tune the pipeline first. And obviously, it's extendable since you can just add further stages. A big black box so far was the kind of language model we are using. So let's first look at the kind of task the model is up to. Basically, in all of the stages, we first have a context. So this is our business scope, maybe some additional requirements. Then we give the language model an instruction to follow, which is either a comparison or comprehension kind of task. And then we always ask it for a numerical result and an explanation. So historically, maybe you could already have done this 10 years ago with encoder-only models or maybe some other models. Google's BERT was quite popular, I think, maybe 8 years ago. And it would be able to give us the numerical output we are asking for. But all of these models had to be fine-tuned first for a specific task. And usually we don't have that much training material. And also, these models would never give us the explanation we asked for. We wouldn't have any explainability. But in recent years, the LLMs emerged, and they don't need any fine-tuning. You can just give it the question and it will answer. So we are going for LLMs. Of course, you are dealing with private company data. So you wouldn't give this to any big vendor like OpenAI. You would never want to do this. And also if you're working with classified projects, then also any other kind of vendor that gives you guarantees of we are hosted in Europe, your data will stay private. Maybe it's also not a good idea. So we aim for locally hosting open weight models. And as a result, we can aim for target hardware that hopefully doesn't cost us too much. So we either do the inference on a CPU, or maybe we have a GPU laying around, but it shouldn't cost us a server that costs 100K or something. And we have found in our experiments that the current models out there are really performant enough for these kind of pipelines, and the exact model doesn't even matter. Just choose anything current that has maybe 5 to 30 billion parameters, is already fine-tuned to chat/instruction type of questions, and that will be enough. So, one last thing I want to talk about is error correction. Now, our demo pipeline is not in particular deep, so it's not a lot of questions, but of course, in practice, you are adding stages for further results. So at some point, when you consider that each stage has a certain kind of error rate, errors will, of course, propagate, and at some point, you will get an exponential blow up. And this is a real concern, that as the pipelines grow deeper, you should apply some kind of error correction to counter these errors, but also to track if the error rates are going up higher than we expect, so we can tackle the problem. There's many approaches to this, but one of the approaches we are using is to model the language model as a stochastically independent process. So what we are doing, we are giving the language model the same question over and over again. And it will each time give us a slightly different output, but at some point, the most prominent answer will statistically occur. And this is the one we pick. This approach is based on a paper by Meyerson et al., where they apply this approach to pipelines with 1 million and more steps, and they can reliably control the process with this. One thing you can apply in this cycle is red flagging. So whenever the language model is clearly doing something wrong, like it's being cut off by the token limit, the answers are too long, or maybe it didn't even give us the numerical score we asked for, so when the output is clearly wrong, we discard this. And if you are familiar with the technical details, in terms of sampling, you should apply different temperatures and top V values if the model supports it, but basically every modern open weight model does this. Okay, takeaways. As you have seen, manual risk assessments done by humans are expensive, so most likely they will only be run non-periodically. They are error prone, but you can try to automate this in a mathematical framework, in this kind of pipeline we have shown. And this clear task decomposition allows you to control the process in terms of being explainable, being extendable, and being able to monitor the error rates. Just to give you some numbers, we have run this demo pipeline with a demo environment where we had 60 assets, 10 risk origins, 60 threats, and 80 vulnerabilities. And that already amounts to 22,000 prompts we are giving to the language model. And that ran in a couple of hours on our lab hardware. That brings me to the end of the presentation. And we as Telespazio are not only doing AI for risk assessment, but also using AI for security analysis. Sometimes we are building zero trust architectures. We are also developing systems. So if you are interested in the topics of the talk or any of these topics, then I welcome you to come to our booth. The location is shown here. We are right in the middle. And thank you for your attention.
Thank you. Do you have any questions? One over there.
Yeah, so thank you for your nice talk. I have two questions. So the first one, so I guess you already experimented with a couple of scenarios with business context, and you got the matrix and so on. I'm wondering, did you validate this over, let's say, some previous results where would humans do something like this, and then the matrix that they come up with the scores versus what you get from the model for a similar project or something like this? And how are those different if you did this experiment?
Yeah, as shown, we basically evaluated this on a demo application, and yeah, we compared the results to our live evaluation, so to say. So we went through the list, and yeah, as Fabian mentioned, the list of results, and yeah, just compared the results with our own feeling, if it makes sense, and if the justification path makes sense. Yeah, so that's basically it.
Yeah, I might also add something. So usually the current models were quite good at this. It's really surprising. And I, as a human, wouldn't have chosen any kind of different score or explanation. But obviously, when you are doing this in practice, take a sample out of the results and do it yourself, and then compare it so you are confident that the model didn't start to hallucinate at some point. Obviously, yeah.
Okay, and then the second question, so you said, so you're using open models and you said the results were fine. So we also had some, well, let's say internal playing around with such models, and the results were interesting when you ask technical questions. Have you also tried coming up with some, let's say, artificial business context, which you can also put in commercial models and you see the diff? So you said obviously the privacy when you put all the information to OpenAI and so on, LLMs, is a concern. But what I'm wondering, if you have an artificial case for some business and then you run this on the commercial models versus basically your trained models, what would be this delta? Have you tried something like this?
It's a good question, since we haven't tried it on the huge models from the open vendors. But I think maybe if you want to discuss the topic at our booth, if you have tried something yourself, then I would happy to share some information with you afterwards.
Yeah, okay, thank you.
Yeah, thank you for the presentation. It was really interesting. So my question is about the likelihood. So estimating the likelihood in risk assessment is quite a hard topic for humans, but I think also for the AI. And I have two questions basically. So how do you make sure that to have an quantitative assessment of the likelihood? So you showed the 0.2 value for the likelihood to occur of the adverse event. Yeah, so how do you make sure it's not hallucinating the system? And the second question would be, so to provide some statistical evidence from previous events that have occurred, so as statistical data to the data set, did you provide this in the context of the prompt? So yeah, those are the two questions I have. Yeah.
I mean, of course, we cannot avoid hallucination. So, but we address this this factor in two aspects. First, what Fabian has shown, we have this error correction approach of performing multiple executions and then, yeah, using the maximum occurrence. On the other hand, the main idea of a fine-grained prompt or fine-grained prompts in a pipeline architecture is to have this traceability. So basically, after every single step, we can see why we received a specific result. So, I mean, if we come up, if we receive a final risk value for a specific scenario, we might be wondering, why did we come up with this? And then the answer might be, yes, because following vulnerabilities are linked to the specific assets. And then we ask, why do we care about these vulnerabilities? Well, because following threats could exploit these vulnerabilities. Then we ask, why do we care about these threats? Well, because following the threat actors we are respecting are capable of causing these threats. So that's basically this justification chain. And yeah, according to these, we might identify issues in the likelihood, yes, but then it's our responsibility to tweak the prompts and to maybe even vary for a specific prompt and specific pipeline stages the model itself.
Okay, thank you.
Just 2 questions. So simple. The first, do you connected with any intelligence groups like Mitre or OTX or anything in order to know what kind of, because finally you have to decide what threats are more likelihood or not. And then this is one question. And another one is specifically for impact, when you decide the probability that something occur, the impact have some specific things, not only for the company at all, maybe some legislation and so on that you have to take in account. So when you test the model, you test in also thinking in the quantity, for example, the company have or the company has lost, or also you test it with the legislation that you don't comply.
So regarding the first question, the set of threats and how we rate the threats, that's basically part of the context establishment already. So as I mentioned, we need to decide which threats we are respecting, but also which frameworks we would like to comply against, right? So if we have external requirements that we need to comply against, ISO 27005, we could follow this pipeline. Maybe it had to be slightly different, or we need to adjust the inputs if there is, it's like in the requirement that we need to follow, the MITRE methodology. Right, and the second question regarding the likelihood. Sorry, what was it again?
When you try to figure out the impact into the company,
exactly. Okay.
You only tested with against, for example, the quantity of the company have, or you also provide information about the legislation that you don't comply and you probably have fine.
Yeah, and yes, regarding this impact factor is basically also part of the context establishment, because we work with plain models, right? These models do not know our company, they do not know our institution, so we still need to fix by ourselves which business processes and which functions are more important to us, and we need to quantify this with a impact value by our own.
No, of course, but did you test this specific thing, or you're not tested?
I mean, we tested this with a demo environment, and
yes,
within this demo environment.
In your demo environment, did you test it?
Yes.
Okay, thank you.
Okay, one question over there.
I was just wondering if you have certain risks that have a different impact on different businesses. Would that distinction be determined? Have you got a knowledge base where you've made these precisions, or is it directly when interacting with the model that you specify these differences?
So if I understand the question correctly, I think the answer also goes in the same direction as with the last question. So what you have is a plain model, and within the business scope, you have to give it that kind of context information. So you either put it as a plain text description inside, and then the model will have to pick this information up, or maybe you are giving it some kind of document, and maybe the model is capable to retrieve this with retrieval augmented generation, but it has to be part of the input.
Okay, so if you've not implemented an additional knowledge base behind that it can use, if there's like unknown risks or new risks and you want to implement those into the model, is there a way to implement them if they're not specifically up to date? With a lot of open source models, they're not fully up to date.
Yeah, I mean, certainly the knowledge will have had something in its training data regarding risk management, and it will likely have seen all of the standards as well. So if you want to update it, either you are updating the model itself, and then you are evaluating again how it performs, or as I said, you put it in the business context as input if you want to stay with the same battle-tested model you have used previously.
All right, thank you very much, Martin, Fabian. Thank you.
Thank you so much.
So you can applaud them.